let's talk about fossilization and kind of just how it works and what's needed for it, and for me to show you my fossils again because yay. So this is kind of just an opportunity to show off my fossils again because I have a bunch of them and I love them. Most of them are ammonite. This one's really cool because it's got rainbow on it. This is half of an ammonite that has, oops, focus, quartz inside of it. It looks really cool. It's from France. This is my trilobite fossil. So trilobite, those little kind of horseshoe crab guys that were all over. This is the one I've got, and it's very cool. Another ammonite that's got like red opalization on it instead of the rainbow. Another ammonite. This one's got ribs on it, but they're not actual ribs. It's just ribbing. My baby ammonite. It's just a little guy. And then this one is actually the same ammonite, it's just the two halves. You can see the crystals on the inside, the quartz, and they actually do fit together, and then the outside is very nice and shiny. So, you got my fossils showing off out of the way. I do have a couple more. Oh wait, where are my shark teeth? Okay, one more. This is a shark tooth I have. I've got a couple of them, but this is the only one I could, find at the moment. I know where they're in my room, but yeah. Shark tooth fossil. So, fossilization is basically just the preservation of stuff through a natural process. So it can be things like animal remains or plant remains, or other things like coprolites, which is fossilized shit, or things like footprints and eggs and stuff like that. So fossilization occurs when something gets very quickly submerged in a layer of stuff, like sediment, so it can be volcanic ash or lava, or sediment at the bottom of a lake or an ocean or other body of water, or something like tar in a tar pit, lots of things. There are a few different processes of fossilization, which I'll probably go over in a part 2 video, but let's just talk about the fossilization itself. So basically what happens, there is a thing, so for example, let's say a dinosaur. A dinosaur dies, and before it can be picked apart by scavengers, it, sinks to the bottom of a lake, and it stays there and gets covered by sediment. And then over 1,000,000 years, more and more sediment builds up on top, and the original dinosaur gets preserved. Or, for example, a woolly mammoth gets trapped in a tar pit and sinks to the bottom and is covered in tar. And then the tar pit, dries up, and then maybe a volcano erupts and blows ash all over it. Then there's just sediment, lots of stuff. Lots of dirt, lots of organic matter. Shit builds up. As the millions of years pass, all of the organic matter get we'll go over it, but generally organic matter gets either decomposed away and leaves like a cast, or it gets replaced with minerals. I'll talk more about these processes, but stuff gets preserved, and then it's dug up and found by people. And then we have fossils. Fossils can range from anything from footprints to actual shit to bugs to plants to even up to this T-Rex. This is the Archaeopteryx, one of the most famous fossils of just a little guy that shows the evolutionary link between dinosaurs and birds, so that's very cool. And here's a common misconception that fossils aren't actually bones. These are no longer bones. I will go over how that works, but there is no organic matter left here, except in a couple of rare cases of different preservation. But most fossils, there are no organic matter. Like the fossils that I have, they're no longer shells or anything, they're just the fossils. They're not the same thing, which is why you cannot carbon date dinosaur bones, because there is no carbon-14 left in the bones. There are other dating methods and stuff that work to find the age of fossils, but you cannot carbon date fossils most of the time. Another very important thing to talk about in terms of fossils is preservation bias. So what that means basically is there is a very strong bias as to what is preserved. For example, soft tissue like skin and skin and organs and muscles does not preserve well at all. It all tends to rot away and decompose very quickly. What is left is the hard tissue like wood or bone or teeth, stuff like that. So, which is why it is incredibly rare to find fossils of mainly soft-bodied organisms like mollusks, like octopus, or worms, or stuff like that. It is very hard because they tend to not fossilize very well at all, because they're just too squishy. Which is why most of the fossils we find are of things like insects with their exoskeleton, or mollusks with shells like clams and ammonites or stuff like that, as well as bones like dinosaur bones, and yeah. So when people say things like octopus are aliens because they have no evidence in the fossil record, it's just because there's not really anything to preserve because they're so squishy. What is also important to note is that fossils in the grand scheme are very, very, very rare. Like, compared to everything that has ever lived, there are ridiculously few fossils. That's because the requirements for fossilization to occur are so specific. Like, you need an organism to die that has things that are able to be preserved, like bones or shells. You need them to be covered very quickly with sediment. You need the sediment to be in the right space. You need, like, all of these different requirements, and it is very, very difficult for those to happen. So most organisms that have ever lived have not been fossilized. There are no fossils of. There's also bias as to where these things are found, because some climates and areas are just way better at preserving things than others. Like, areas with lots of loose sediment that can settle very quickly are way better at preserving things than areas that don't have a lot of sediment and have just dead things just sitting out for a while. It is also very difficult to get fossils of large animals like this that are complete, because most of the time when a large animal such as a T-Rex dies, their body is picked at by scavengers and like other things, and they just get scattered all over, and the skeleton is almost never complete. So that is very rare to find more of a couple bones of a large animal such as this, because the bones tend to get scattered because that's a lot of food, so things would take advantage of that. But overall, fossils are very fascinating, and come back to part 2 where we go over the different processes of fossilization that can occur.